What's going on, everyone? In today's video, we're going to go over a couple application problems of parallel and perpendicular lines and how you can get the right answer every single time. Let's take a look. So what can we say about line 1 over here in red, and what can we say about line 2 over here in green? Well, if you look at them, they are perfectly parallel, all right, which means that they are never going to intersect, which also means that they have the same exact slope. They have the same exact rise over run, and that's exactly why they will never cross, because they have the same constant rate of change for their rise over run, meaning that they will never intersect. They will always be parallel, running side by side to each other for infinity. So two lines are parallel if their gradients are the same, if their slopes are the same, if their gradients are the same, if their slopes are equal, okay? So if you're looking at two equations, y equals mx plus b, or y minus y1 equals equals m times x minus x1, if those have the same values of m, then you are going to have parallel lines, meaning that they never intersect, they run side by side to each other for always in eternity. Now, let's take a look at what a perpendicular line might look like. We are going to look at these two lines. We have L1 right here, and we are going to go ahead and draw it like that. And we have L2 going this way. Let's take a look at our gradients and see what we can come up with. Let's take a look at our slopes and see what kind of difference we have here. So I see a nice point right here, and I also see another nice point right here. And if I take a look at what I am doing here, I'm going up from 4 to 5 to 6. I'm going up by 2. My run is 1. So my slope of L2 is going to be 2. And then if I look over here at my red line, well, let's see here. Here's a good point, and here's a good point. So I'm going to go down and over. I mean, I have -1 on my rise and then +2 on my run. So my slope of L1 is going to be -1/2. Now let's actually write that out so it looks a little bit neater. So let's say that my slope of line 1 is equal to -1/2. And then my slope of line 2 is going to be +2. And what you'll notice is that these are actually, in fact, especially, you'll definitely notice it if I write this as 2 over 1, but you'll notice that whenever we have perpendicular lines, meaning that they are making a 90 degree, that they are orthogonal to each other, they're perpendicular, you'll notice that what we do is the difference between these two is that the numerator and denominator are switched, also called a reciprocal. And then we also change the sign. We change the polarity. So if one of my lines was -1/2, that had a slope of -1/2, well, then my other slope that's perpendicular to it, this would become a positive. That's why we don't see anything here. And then I swap 2 with 1, which is why I just write 2. So again, we call these opposite reciprocals, okay? Meaning that we are flipping the fraction, the numerator to denominator, and then we're changing the positive to a negative or the negative to a positive. Take a look. If we actually multiply the slope of, let's say, line 2 times the slope of line 1, what do we get? Well, the slope of line 2 is just +2 over 1, and then the slope of my line 1 is -1/2. And what is that going to give me? That's going to give me -1. So anytime that you multiply the slopes of perpendicular lines, you'll get the answer of -1. And perhaps another way to think about that is that if you multiply two slopes together and that product is -1, you have perpendicular lines. You have lines that make a 90 degree angle. You have lines that are orthogonal to each other. Take a look at an example. So let's say that we have two cargo ships and we're given their lines of trajectory, or we have to figure out what their lines of trajectory are. And let's say that in each of these cases, we want to determine if this is parallel or if this is going to intersect. Okay, so let's go ahead, and I see that L1 is passing through the points 2, 4, and -1, -2, and L2 is passing through the points 0, -4, and 2, 0. So remember what this is asking. It is asking us if they are parallel. So if they are going to be parallel, it means that they have to have the same exact slope. And based off what we have covered in earlier videos, we know that we just have to find the slope of L1. I know that looks like a 4, but L1. I know that I'll have y2 minus y1 all over x2 minus x1. So the slope of L1 is going to be equal to -6 over -3. The slope of L1 is equal to +2. So now if my other slope is different, it means they will intersect, because the only time the two lines don't intersect is if they are parallel, meaning that they have the same exact slope. So let's go ahead and in a different color, I'll go ahead and write the slope of L2. It's going to be equal to what? Y2 minus Y1 all over X2 minus. All right, so if I simplify this down, I'll have the slope of L2 is equal to 4 all over 2. The slope of L2 is equal to 2. So since these two slopes are equal, that means that the same constant rate of change. They are going at the same exact rise over run. They're going at the same slope, going at the same gradient, going at the same rate of change, however you want to word it. And so these two lines are never going to intersect. They are parallel. So in this example, they are parallel because both of their slopes are equal to each other. Okay, so hopefully that sheds a little bit of light onto that. All right, so let's take a look at some parallel lines graphically. All right, so let's say that we have a tractor that's pulling a plow to make 3 parallel straight grooves for planting seeds. Okay, so we basically put a Cartesian coordinate on top of a farm, and we want to get these lines to be parallel in order to plant seeds in these non-intersecting grooves. So now let's say that the graph of one of these grooves, L1, is given in this diagram. So we want to get an equation of a groove L2 parallel to L1, except this time we want it to pass through the origin. We want it to pass through 0, 0. So what we have to do is find the slope of this line right here, because if they are going to be parallel, then that means L2 will have the same slope as L1. So the slope of L1 will have to equal to the slope of L2. And since we want to pass it through the origin, that actually makes our lives a lot easier, because another way of thinking about that is that this is our y-intercept, and that's 0. So we want this kind of parallel line to be kind of sort of like that. Obviously, it's a pretty terrible straight line. We want to cut through 0, 0 and not intersect L1, meaning we have to have the same slope. So let's find out what the slope of L1 is. So I have a good point right here. I have another great point right there. So if I just drop this down and drop this over, I went down 1, 2, 3, and 4. Sorry about that. I went over positive 1. So my slope of L1 is equal to negative 4, which is also going to be my slope of L2. So since I know my slope is L2 and I know my y-intercept is 0 because I want this to be parallel to L1, and I want to pass through the origin, that means that the equation for this line, y of L2, is going to be equal to negative 4x, and then that is it. Just negative 4x. Because again, my y-intercept is going to be 0 because it's passing through the origin, and it has to have the same exact slope as L1, which I determined to be negative 4. So as long as you got y of L2 is equal to negative 4x, you're in good shape. Okay, so let's say that we have a plane that is going to fly along a straight line L1, and it's given an equation y equals 2x minus 5. That is the equation that we're given, a nice linear equation. And now we want to determine the equation of another line, L2, which represents another plane that's flying at the exact same altitude. So it's kind of taking on the role of an air traffic controller. And they do not want to intersect. That would be really bad. It means they hit each other. And it wants to pass to the point 3, negative 1. What is that equation? So first things first, let's go ahead. Let's plot L1 as 2x minus 5. So again, I'm going to go right here to minus 5. My slope is 2, so I can just go ahead and go 1, 2, 1, and then connect those dots like so, like that. All right, so now we want to figure out L2. We do not want it to intersect, and we want to pass to the point 3, negative 1. So remember, if they are not going to intersect, that means that they are parallel, which means that they have the same exact slope. So what this means is that your line for L2 should have the same slope, which in this case is 2, but we have no idea what B is. But what we do know is that we want to pass through 3, 1. So 3 would go in for x, and then negative 1 would go in for y. Let's go ahead and do that. Output of negative 1 is equal to 2 times 3 plus b. I get negative 1 is equal to 6 plus b. That'll give me negative 7 is equal to b. And there we go. I now actually have my entire equation, because my line for L2 has the same slope 2, except this time it has a y-intercept of negative 7. If I plotted that out, I would have negative 7 right here, go up 2, over 1. And if I graph that out, you'll find that it is going to run exactly like so. So again, they're running nice and side by side. They're never going to intersect, so everyone is safe on the plane. So hopefully that sheds a little bit of light into why parallel lines have the same slope, how we can deal with these problems algebraically as well as graphically. And in the next video, we'll go ahead and take a look at perpendicular lines a little bit more closely. See you in the next one.